Hello guys, and welcome to our video for today. Today we'll be considering um, regression analysis using SPSS. Remember I promised us that we are going to learn some very important analysis using all the software packages we'll be using, and regression happens to be one of such analysis that we're going to be treating using all the packages we'll be using subsequently, that is Python and R. So let's jump straight into that. What's this data set? Let me explain the data set. This is a data set for a state, United States, a real life data set. This is the cost of how much people spend on healthcare or cost of healthcare. So they are trying to predict the cost of healthcare. This is the date, this is the region, this is whether their sex, male or female, their age, their marital status, alcohol, how much alcohol do they take, cigarettes, how much cigarettes do they take, exercise, how much do they exercise per hour, and the cost they spend on drugs, or the cost they spend for healthcare maintenance. So we want to create a model that can predict the cost of maintenance for health. I want to check also for variables that affect overall cost of maintenance. Let's also look at it from here so that you get what I'm saying. What do they say here? Survey average consumption of alcohol beverages per week. Okay, average consumption of cigarettes per day, average hour of exercise per week, total care costs declared over 2020. So these are just the labels of the data. So let's go straight into the analysis. We're going to go to analyze, we're going to go to regression, if you guess that right. Then we'll go to linear regression. Now our dependence variable, what's our dependent variable? Remember, total care, total health costs. And then our dependent variable, what do we think are the things that can affect this? Remember, initially when we're doing regression, we mentioned linear or bivariate regression and multiple regression. So in this case, I'm going to be doing, first of all, a linear regression. I'm actually kind of inquisitive about this, whether sex, gender affects that. So let's just quickly check this. So in this case, we just have one variable, right? Then we can just I'm going to explain these other ones later, but let's just check this. All right, so from what we have here, it is not significant. I think I expected that. Remember, I told you that the very most important thing is this ANOVA. I'm not going to spend time to explain this. All these have been done in our previous video. I'm just going to rush through them, just like a brief recap. I won't be explaining them in detail. This is just the variable that was entered. So what this is just telling us the variable we used for our independent variable. So it's gender we used. So here, this is our R. Remember our R, this is our adjusted R. This is our ANOVA. This and these are similar with that of Excel exactly. So remember, this our R tells us the number of variation in the dependent variable that was predicted by the variation in the independent variable. That is this R here, this R squared. Then this is telling us whether the regression line is significant. From here, you are saying that it is not significant. Okay, I guess we have confirmed that. So let's try multiple now. So multiple linear regression, we still go to linear. So we already have this here, we already have this here. So let's add more to our independent variables. Let's enter, I think there are many funny things we can investigate. To investigate if marital status affects health. So we push those ones here. So we pushed how many variables now? We've pushed, I think we've pushed about 4 now. So now let's check our statistics. What do we have here? Do you want descriptive statistics? Do you want R square change? Do you want to be seeing your R square change? I will show you when we use this. I don't think this is important now. Part and partial correlation. If you want correlation, you can also get that here. Plots, whether we want our plots. Sometimes you might require to plot your residuals, so you could do that here. Okay. Do we want any of this here? Okay, I don't think we need any of this here. Then options. Okay, entry and removal. Okay, we can adjust this later, but for now let's leave this. All right, I think we're good to go. I would click OK, and then we have our regression. Let me minus this so I don't block our space. So now this is the ANOVA, this is the multiple regression ANOVA. So we're seeing that the regression model is significant, right? It's obvious that our regression model, this is all the entered variables, average hours of exercise per week, sex, average consumption of cigarettes per day, So all these are the what entered variable. Then what next? We have our r, and we have our r square, right? Adjusted r square. Then our ANOVA. So it's telling us that this regression line is a good predictor, which is awesome. So now this is not telling us each of those. Now these are our beta values. These values under this B, we use this unstandardized coefficients to get our equation. Is that okay? So this is what we're going to use for our equation. Remember how to get your prediction equation. All those are in the Excel video. You can check that out. So these are constants. This text, this is alcohol. This is cigarette. This is average hour exercise. So all these are the different factors. I see that from here, all of them are significant. Everyone is significant because our alpha level is 0.05. This is less than 0.05. So even gender here is significant. So that is it. But let me show you one more thing in SPSS that makes SPSS in Excel quite unique and powerful. Let's still try this again. Regression. Now there is what we call method. Now we're using the enter method. Now all these are different methods in Excel, in SPSS, for doing regression. Now if you pick any of this method, it's going to be iterating one by one. For instance, if we pick the forward method, what it's going to do is that it's going to be putting the variables one by one to see which of them has much more to help you get the best model. So in this case, remember we added several things and all of them were perfect. So it's going to be checking to see, picking them one by one, the independent variables, to see which of them will give you the best model or the best R square. So let's try this. Now here is where we're going to have options now. So now we are going to tell it what should be the condition for us to add a variable. So if our entry should be 0.05, that means we can enter if you meet a condition of 0.05. So we can leave this. So we can say continue, and then under the statistics we can see R square change, so that we can be detecting the change in the R square to see whether it's doing a good job for us. So I think we are good to go. You can click OK. So let me off this one. Don't need this, so that we can focus on what we are working on now. So first off, we have, it started with, he added average consumption of cigarette per day. He now added average, so hour of exercise per week. He added this before he added gender. So now from here we're going to see that when it added this, the first model contained only, the first model is like just a it's just like a simple linear regression, because it's only one variable, the one that has the highest impact on the R square. Then the second one, he now added the next one, he now added the third one, he now added the fourth one. So it's obvious that so from here you can now investigate which of the model do you think will serve you better. But let's look at the R square. From here we have an R square of 0.429. Our R square change is significant. Here we have 5.2. R square change is significant. 5.38. R square change is significant. Here we have 5.45, but the R square change is not significant. See the R square, the R and the R square changed. Look at the R square change here. That was the extra thing I ticked so that we can see the change. So I will see that there's a change here. Look at the change when we added this one. Look at the change when we added this one, and look at the change when we added this one. So the R square was 4.29, went to 5.20, 5.38, and finally went to 5.45. So sorry, this R, I mean this, it went from 1.84 to 2.70, 2.89, and 2.97. So let's check our ANOVA. Our ANOVA for our first model is significant, ANOVA for our second model is significant, ANOVA for our third model is significant, and ANOVA for our fourth model is significant. Why? Also here we have the same thing also. Our beta for each of them. For our first model we have this beta significant, second model, third model, and like that. So excluded variables, that is if you have cases where all of them, maybe there are some cases where they reported gender but they didn't report anything. Maybe you have empty cases. Some people, mostly questionnaires, people don't fill everything, they are always empty spaces, or you can expect empty cases. So this is just dealing with that. So let me explain the backward one, then I think maybe we can research the rest. I'm going to send a material that will explain the rest for us. If you still go to regression and you go to linear, if we decide that we want backward, and we click OK now. Let me off this so it won't distract us. Now this is our regression line. So this is our model. It entered all this. Now none of them was removed. Why was none of them removed? That was because none of them met the condition for being removed. Remember that there is a condition for being removed. None of them met that condition for being removed. That's why it still included all of them, because all of them were quite significant. Let's try a case where, as I said, let's try a case where we will see something in the remove tab. Regression, linear. I said it's from the options. So let's work with this. 0.01 should be the entry and 0.02 should be the removal. So click continue. Okay, and we notice that here we have removed this. So this one has been removed because it didn't meet up with the condition. So these were the ones they used for the model. These were the ones they used for the model. So let's see. So here they used, so these were the values. Let's explain this a bit. So these are ANOVA for model 1 and model 2. So we have only two models now. The model, this model with this entered value, and the model where this one was removed. So we have two models, and then we have the R square for the two model. This model has all these values, while this one have all these values here. So here also we have model 1 is significant, model 2 is significant. This one is giving us our coefficients for each of those values in each of those models. If you check our first model, everything was intact, but in the second model they removed the other one. So this is where I just wanted us to have a scenario where you understand how this first table works. Okay, that just tells us how this first table, when you see entered variables, it means the variables that were used for that model. The removed variables are the variables that was removed in that model. So then let me explain one more. The next thing I want to explain is still under the regression. Another method is the stepwise method. The stepwise method is like the combination of the forward and the backward method. So this is how it works. So here we have three models. Let me off this one so I won't confuse ourselves. So any result we're seeing here, we know it's for this method. So we have average consumption of cigarette. So this one met the condition, that's why it's joined here. This one too met, and it was used to create another model. This one too met, and it was used to create another model. So these are the listing for the three models that were created. Look at the variables that was used. Stepwise, the good thing about stepwise is that when he wants to create another model, he doesn't mind. It will just check among all the ones that were there. Anyone he feels that will add to the R square, whether it was something it has removed before, it can still bring it back. So it's not like the forward or the backward method. Remember, the forward method will start from 1 and increasing gradually, while the backward method will do all of them and start removing gradually. But this one does the both of them interchangeably. Then we have our coefficient, we have our excluded variables. So that is just it about regression, and this is what makes regression in SPSS quite unique. There are cases where people are interested in this, especially for very strict analysis. So I just thought to mention it. I'll still send more materials on this. I can't treat this exclusively in this video, but I'm going to drop materials on this so that you can take your time and go through them and digest it properly. So that is all for regression in SPSS, and bye for now.